Yeah, I think it's recording. Okay, hello, Mallory. We are skipping 12.1. We're going to 12.2. 12.1 is like sample spaces. It's fairly short and sweet, but I want to do a couple sections from chapter 12, and then that stuff we will not take a chapter test over, but that will help hopefully pad your grade a little bit when we take the semester test, because hopefully this stuff is fairly easy for you. So we need some easy stuff to end the year so that you have some free points on your test, hopefully your semester test, okay? So probability and counting, they start by talking about like different events and event diagrams. So let's say, for example, like event A, let's say we're rolling a dice, right? Or a die. Is it die or dice? I don't know, we're rolling a die.
Die is one.
We're rolling a die. Okay, we're rolling a die, D-I-E. Boop, boop, boop. Okay, and now I just looks like I said I have die on my paper. Whatever, we're rolling a die, okay? And event A is the probability of me getting an even number, right? Okay, so if I get an even number, what numbers could I have rolled?
2, 4, 6.
2, 4, 6. Okay, that's event A. Those are my things that I could get for event A, okay? Now let's say I have a number less than 2. No, let's go less than 3, okay? Numbers less than 3 is event B, and that would be just 2 and 1, right? Is 3 less than 3? Is 3 included in that? No, just less than 3, there is that, okay? Now, we have two things that are happening, and we have something called the union, which looks like A, U, B is a union, okay? Now, when I think of union, I think of marriage. I don't know, like this union of matrimony, whatever, okay, union. That's what I think of whenever I think of union, okay? So let's relate this to a union, right? Okay, let's say these are all the numbers that I have, and these are all the numbers that my husband has, right? And when we come together and we get married, the things that we have all together are everything, right? So in the union would be the numbers 1, 2, 4, 6, in that order, right? We would own every number on a die except for the numbers 3 and 5. Got it? Yeah, that's a union. Okay? A, U, B. All right? But then they have something also called an intersection. All right? And an intersection is A intercept B, and it looks like an upside down U. Okay? And the way that I think about this is you intersect at the top of a hill, right? Like it's a hill, and the top of it, that's where you're intersecting, okay? And an intersection is where they intersect. So looking at this guy right here, they have A intersect B, and what's in that intersection? 2. It's like the things that both sides have in common, right? So if we're talking about like DVDs, like these are the DVDs people even collect DVDs anymore? Probably not, right? Or CDs, like you don't even, whatever. Anyway, so way back in the ancient times, we collected CDs and DVDs and whatever. So these are all that I own. These are all that my husband owns. And because we have different tastes in music, there's only one DVD that we have that is an overlap or a copy, right? Like that's the same. That would be the intersection. 2. That's the only thing that intersects, right? Now, what happens if you don't have anything that intersects? Like, let's say my tastes are completely different than my husband's tastes and there's nothing in here. What do you put?
0, nothing.
You could put 0 with a line through it. Or they have something that's I don't like as much. They call this the empty set. It's literally like the curly Q brackets, but with nothing inside of it. I don't like that as much because somebody could be really mean and go and write a number in there if they wanted to, whatever. So I just do a circle with a line through it if there's nothing in common. There's nothing in there. But that's how that works. What?
You said, is it up for debate?
What?
Who knows, and then someone can just add it on there.
Right. Like, if somebody wants to be really mean and you put a bunch of empty sets on your paper, like Matthew could go through and put the number 3 in each one and then you'd get it wrong, right? Like, I don't like that as much, right? I'd rather do a circle with a line through it and then there's no debate, right? Okay, so union intersection, yeah?
But with that theory,
It's a U or a like an N kind of, right? Okay, let's do an example. Example 1. A fair dice is rolled once. Let A be the event of rolling an odd number, okay? The possible outcomes for event A are all the numbers on a die that are odd, or 1, 3, 5. That's what they have listed there, okay? Event B is the number of rolling greater than 3. Okay, so the possible outcomes for event B are all the numbers on a die that are greater than 3, which are 4, 5, and 6, right? 4, 5, and 6. Okay, now they're talking about A, N, B. What does that mean? Is that the union or the intersection?
oh,
This is intersection, where they're meeting at the top of a hill, right? Okay, so A intersect B contains blank of the outcomes that are in both sample spaces, A and B. What do they want in that blank?
One. They just have one outcome there. Right.
Contains one of the outcomes that are in both. I would say it contains all of the outcomes that are in both sample spaces. Does that make sense? All that's in both? Confusing. Whatever, I don't like that blank. Anyway, so if it helps you to do it on a Venn diagram, here's event A, here's event B, the numbers 1, 3, 5 are over here, the numbers 4, 6, or 5, 4, 5, 6 are over here. What is in the intersection? 5, right? 5 is in the intersection. Okay, now, let's do also what's in the union.
1, 3, 4, 5, 6.
1, 3, 4, 5, 6. Everything except 2. So union versus intersection. Make sense? We got it figured out, kind of? Okay. All right, example 2. Let's do, no, we're good. Okay, let's do this one. Example 2. They want, now they're talking about decks of cards. Do you guys know your decks of cards? Okay, if you don't know your decks of cards, here they are, right? We have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and we're assuming that there's no jokers in a standard deck, okay? But then you have a spade. Is that a spade? It's a shovel, right? Like a spade in gardening, right? Then you have a club, which looks like puppy feet, whatever. And then you have hearts and you have diamonds. Those ones are like the easy ones. Spades and clubs, for some reason, I just can't figure that out, okay? So there are 4 aces, and they are of those suit. There are 4 jacks, and they're all of those suits, right? Okay? Then you have a joker, and you have a joker over here, whatever. We're not including those in our standard deck, okay? How many cards are there altogether?
52.
52. 54 if you include jokers, but 52. It would be like 4 times 13. There are 13 cards and 4 of each card, right? So 4 times 13 is 52, okay? Have you guys ever heard of 52 card pickup? That's how I remember that.
Yes.
You know what 52 card pickup is? They didn't know what that was this morning. I said, go home and tell your siblings that you're going to play 52 card pickup, right? You dump all the 52 cards on the floor and then they have to pick them up, right?
Yeah.
Okay. Anyway, so 52 cards. How many of those cards are black?
26.
26, half of them, right? How many cards are red? 26, right? Got it? How many cards are sevens? 4, right? Make sense? Do we know how this works? Okay. All right, so here we go. Example 2. A card is selected from a standard deck of cards. What is the probability that the card is a queen and is red? Okay. A queen and is red. How many red queens are there? 2 out of
52.
52, which is
126.
126. That's the answer. Okay, now, and is another way of saying intersection, right? A intersect B. Okay, it's in the intersection. So look at how they have it drawn out. The word and intersection are the same because it's like a little A right here in the middle, right? And intersection. Okay, so we have A and B. A, inside A, we're talking about queens. How many queens are there? 4. Inside B, we're talking about all the red cards, which is 26, right? How many are queens that are also red? 2. And this is the intersection, 2 out of 52, right? Okay, and so that's how they do that. So they're having you think about it in terms of intersection. All right, 3. Now we're talking unions. A fair dice is rolled. Let A be the event of rolling a number less than 5. Okay, in this first blank right here, numbers less than 5 are 1, 2, 3, 4, 4, 3, 2, 1, however you want to do it. Okay, let B be the event of rolling a multiple of 2. What are multiples of 2 on a deck? 2, 4, 6. Multiples of 2 are 2, 4, 6. A union B contains all of the outcomes that are in both sample spaces. I don't know. Maybe that's what that says. So in the union, I've got over here and I've got over here. I've got 1, 2, 3, 4, and I've got 2, 4, 6. So 2 and 4 would be in the intersection, right? So A and B together, or A intersect B would be 2 and 4, right? But in the union is everything that we all own together, which is 1 and 2 and 3 and 4 and 6. 1 and 2 and 3 and 4 and 6. That's the union. Make sense? Okay, in terms of and or, which one is and which one is or?
And is the A.
And is the upside down A. The only numbers that are in A and in B are in 2 and 4, are 2 and 4, right? But union is another way of saying or, because if I want to know the numbers that are in A or in B, it would be 1, 2, 3, 4, 6, right? So that's another way of thinking of it. A union is or, because I don't care if it's one side or the other. If it's in both, great, right? One or the other or both. And then intersection is and that's just the people that are in both, right? Okay, let's go down to this one. Let's do the check really quick, okay? Because this one's a little bit confusing, okay? Here we have this thing going on. We have colors, what?
What do you say, both?
I don't know. Everybody makes fun of the way that I say it. I make it sound like there's an L and an I can't. Both,
There's no
both,
L.
both. I know. I have a speech impediment. I'm sorry.
L.
I know, but it comes out my mouth that way. I have a speech impediment. Whatever. Anyway, both. I will try. But it just sounds weird. It's like my lips like are frozen. I can't say it that way. Both. 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 Both.
Both.
I don't like it. Both.
If you say
Okay.
words so many times, it's just
Bah.
weird. Like if you say like
I know.
calculator.
Calculate. Yeah, I know. It's like blah, 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 blah. My tongue is frozen. Okay. Anyway. Okay, so in this check right here, let's do this one real quick because it has a spinner. Let A be the event of landing on a blue section. Okay, which sections are blue?
15 and 7.
15 and 7. This is event A and this is blue. Okay, 7 and 15. Okay, event B is a number divisible by 3. So what numbers on this spinner are divisible by 3?
3, 9, 15.
3, 9, and 15 there because there's no 6 on there, right? Okay, I want to know the union. So if I'm just looking at these two unions together, I have 3 and 7 and 9 and 15. Okay, what's in the intersection?
15.
Just 15, right? The only number that is in both of them is 15. Yeah? Good? Not so bad. Okay, the last thing is talking about a complement. Okay, so let's do this. They do this to you on the ACT and on MAPS testing and everything. So let's say we have 4 yellow marbles, and then we have 5 green, and 6 blue, and 4 red, and 9 orange, right? And if I add all those together, I have no idea how many that is. 18, 28. 28 together, right? Okay, the complement is me asking, I want to find the probability of not blue. How do you find the probability of not blue?
Winners or a total?
Yeah. Total is 28. How many are not blue?
4, 9.
No. What are you doing?
I don't know.
How many are not blue? How many are blue?
6.
6 are blue. How many are not blue?
22.
22.
Okay, I see.
That's how you calculate a complement. Don't add these together. Find how many are blue and then find out how many are not blue. Does that make sense? Okay, so that is what a complement is. This would be like 11 over 14, right? So complement involves like subtracting instead, right? Okay, all right, so here's the deal. Let's say these are the geometry kids and these are the chemistry kids. Do we have somebody that's in geometry and chemistry in here?
Most of us.
Most of you? Delaney, are you in chemistry? Woo! Delaney lives over here, right? Because she's in geometry but not in chemistry. The rest of you, most of you are in here. Olivia's over here as well because she's in geometry but not in chemistry, right? Can you be in chemistry but not in geometry? Do you have like Connor in there? Is Connor in chemistry?
Yeah.
Connor. Okay, Connor's in chemistry but not in geometry because he's in trig, right? Okay, so you don't have to be in one or the other. We have a lot of people. What? Jack's in chemistry but not in geometry. Cool. So there's a lot of you that are in here, but you don't have to be, right? Okay. So if I look at this list and I say, who are not geometry kids?
Connor and Jordan.
Connor and Jack. The people who are not geometry would be in that side. Okay. Or the people who are in neither, right? Is there some people that are neither geometry or chemistry? Like, what about like Reese Malati? Is she in chemistry? No, she's in physics, right? So she would be also in that list of not geometry, right? She would be in the complement. But where does the complement, where does not geometry or chemistry live?
Not there.
In the white, right? That's not geometry or chemistry.
You wouldn't add them.
What?
You wouldn't add them.
We would have to know how many there were total. So sometimes they will do this to you. Sometimes they'll say, okay, geometry is here, chemistry is here. There's 10 geometry kids, 14 chemistry kids, 8 of them that are overlapping, right? And then we've got like another 12 students that are in neither. So they would have to give you that information as well, right? Okay. So who is not chemistry? How many are not chemistry?
14, or wait,
Not chemistry. What?
On this?
10 plus 12.
Yes, these are not chemistry and these are not chemistry, right? Okay, now they do this to you for complement. They do like an A with an apostrophe. That means the complement. Sometimes they'll do like A bar for a complement. Okay, either one. Both of those mean the same thing. So either an apostrophe or an A bar, that means the complement or like the opposite. Okay, let's do an example. Example 4. This is the last one. Panju. I don't know where they get these names from. Whatever.
Just be like Jack.
What?
Why can't they just be like
I don't know why.
Brad?
Because they have to be diverse.
Open it.
Yeah, right. Like
Thomas?
Thomas. Yeah, like let's get some ones that I can.
Timothy.
Juan.
Nathaniel B.
Whatever. All right, subscribes to a movie streaming service for a movie night. He is going to let the program randomly select a movie from his list of favorites. What is the probability that a comedy movie will not be chosen? Comedy movie will not be chosen. We added these together earlier this morning and said that this was 350 different ones. Okay, how do I figure out how many are not comedy?
350 minus 112.
350 minus 112 is, I don't know, 238. Okay, so what's the probability of not comedy?
238 over 350.
238 over 350, which is like 17 over 25, I think. I don't remember how they reduced. 17 over 25. Something like that, right? Which is, can you do that percentage in your head?
17.
Times 4, that's like 68%.
68%. Look at you go. 68%. I took a times 2 and then 2 again. 34,
That works.
68, yeah. So anyway, there you go.
Just take 4 times 10 and then times 7 and add.
Right, right. Yep, that'll work too. Okay, good. Complement is whatever, like not that, right? All right, 2 through 14 evens. One more thing. What are prime numbers?
2.
1.
Is 1 a prime number?
I cannot remember.
Some books say yes, some books say no. We will say yes. How about that? Okay, so write this at the top. Prime number, we'll say 1 is a prime number. Is 2 a prime number?
Yes.
Yes, 2 is the only even prime number, yeah? Prime is if only 1 in itself goes into it, okay? 3, is 3 prime?
Yeah.
4 is not, 5 is?
7.
7,
11.
9,
Nope.
No.
not 9, 11,
Yeah.
13, 15?
Nope.
No, 17?
Yes.
Yes, 19,
Yeah.
21?
No.
Nope, 23,
Yes.
25?
No.
Nope, 27?
Yeah.
Nope. 27 is 3 and 9.
Oh,
yeah.
shoot.
29, yes. 31, yes, and continue on, whatever. Blah, blah, blah. That should give you a rough idea. So those are prime numbers because they do ask you a question on that, on those.
1, 2, 3,
Okay,
4, 5, 6,
good?
1 over
All right, if you have questions, you can ask. All right, there we go. What?
Major.
You may. That wasn't the question I